Okay, so it's my pleasure to introduce our speaker today, Michal Engelman. So welcome. Michal's been here several times. She gave a back talk about 5-6 years ago, yeah, and has been a speaker in our demography workshop, but it's the first time here at the Brown Bay. So welcome. Michal is a professor at the University of Wisconsin. She started out at Johns Hopkins, where she did her PhD and a postdoc, before becoming an assistant professor at Chicago, and then was lured away to Wisconsin, where she started as assistant professor, is now promoted. So we're just delighted to have you here. She's worked on a number of areas. I first met her in the formal demography world, but she also does a lot of work on health disparities, and of course on aging, which is what she'll be talking about today. And she has a new big grant from NIH on studying epigenetics of aging people, right? Okay, which is getting started, but this is a kind of ongoing project that has a forthcoming paper in demography. Yeah. Right. So, welcome. Do you want feedback on this? Is it all you got stuff that's going forward, right?
Yeah. So this is a combination of a project of a paper that's forthcoming, but
appreciation of what's coming out of demography and constructive criticism of what's coming forward. Thanks so much.
Thank you, Josh, for the introduction. Thanks to all of you for coming today. So as Josh was mentioning, my work has started out in formal demography and has also covered health disparities and health inequities. And one of the things that I'm trying to do in this paper, particularly in the piece that is less developed, is actually try to say that these two worlds are not so different, and that formal demography in many ways can perhaps give us some insights into thinking about health disparities in a way that we don't normally consider. So I'll be curious to hear your thoughts about that. And I should also say that this is a project that's joined with Heidi Jackson, who's a graduate of our PhD program at Wisconsin, and who's now at the University of Maryland. And so how do we think about aging and health? I think that when we think about aging and health, we as sort of regular people, and also we as scholars, population scientists who think about health and aging, actually have sort of two competing intuitions that we keep in our heads at all times. On the one hand, we have this idea that I think is very common in sort of population health research and in public tropes of discussion of aging as kind of this time of continuous slow decline in health, right? So you can see this a little bit, right? There's this notion of like the 7 ages of man, right? It comes from Shakespeare and As You Like It, and this idea that, you know, development is a lifelong process, but there's kind of like this curvature, right? This idea that aging is this time and gradually sort of maybe health and capacity and functioning are slowly giving way. So this is one idea. And then there's this other intuition that comes from actually knowing older people or going through the aging process ourselves, which is that health in aging is hugely variable, right? A lot of people are very healthy for a long period of time. A lot of people maybe experience some health declines, but they also get better. Sometimes when people do experience these declines, they are kind of this slow, gradual sense that we think of, but sometimes the decline can happen very fast. There can be unexpected mortality, right? Sometimes people are going along and things happen unexpectedly, right? And again, these patterns of sort of recovery are not unheard of as well. And so these things are competing senses, right? Is it gradual decline, or is there this big variability in kind of multiple kind of non-monotonic and non-continuous ways that aging can take place? And I think, you know, one tempting way to try and reconcile these two competing intuitions is to do something that, as demographers, a lot of us do, which is to say, well, this is just the difference between taking an individual versus a population level perspective. Right? After all, so there's this individual stochasticity. We are all different. We all have unique life course trajectories, but there's some kind of regularity in the pattern of aging that we can use population data and population thinking to describe. And in fact, this is not just kind of our common intuition in thinking about this in demography. Most research on health and aging basically collects data from individuals through surveys, but then uses statistical and epidemiologic methods to make inferences about populations, right? And so it's super compelling, right? And it seems super intuitive to assume that in fact these two different intuitions about gradual change or kind of more uneven, something that I'm going to call a punctuated equilibrium approach, that these things are complementary rather than contradictory. But one of the things that I'm going to try and convince you of today is that they're perhaps not so complementary after all, and particularly what happens if in fact looking at things from an individual versus a population level perspective actually leads you to support these very different intuitions from one another, and that not only does this matter in terms of how we model and understand patterns of health, but it might actually have implications for how we understand the evolution of health disparities over the life course, and therefore the kinds of interventions that we think are perhaps best positioned to mitigate health disparities. So, thinking particularly about this idea of inequality and how a variety of forms of social inequality and stratification across the life course might have implications for health. These questions have a long tradition in studying gerontology and health. So in particular, the life course perspective has taught us that whether you think about it from an individual kind of psychological perspective of individual lifespan development, we recognize that people become increasingly differentiated as they move through life, right? Everyone goes through their unique experiences, and you might imagine that you would expect to see more variation in a particular measure of health among a group of, say, 75-year-olds than you would among a group of 5-year-olds, just because people have gone through life. There have been more chances for things to be different. And then adding to that kind of insight from developmental psychology, the sociological idea of cumulative disadvantage suggests that this is not just because of differences in individual kind of baseline attributes and experiences over the life course, but there's also a structural dimension to this, right? Some people, due to kind of a variety of circumstances that have to do with the families they're born to, the places where they live, the kinds of opportunities that are available or not to them over the life course, may end up sort of developing in their health in different ways over time, such that some people who are fortunate to have a variety of advantages in early life may reach old age in a very healthy and active state. Other people may reach old age with a greater burden of disease and disability, and so this combination of individual differences and structural difference will generate greater inequality in health. And the fundamental causes perspective, right, from social epidemiology, that tells us that that social conditions will fundamentally sort of impact a variety of different health outcomes in different ways across the life course, resonates with that idea. And all of these theoretical orientations lead us to expect, right, this relationship, which we may be able to and often do try to empirically tease out using the kind of population health data that we collect, to find these relationships that they would suggest that exposure to social and economic disadvantage at various points across the life course, and particularly if it accumulates at multiple points across the life course, will manifest in disparities that we might be able to observe between people in very basic things like mortality and how long people live, but also in health as well. And so the issue, do we see this, right? The evidence is mixed. It turns out that when we look at the data, we have a lot of evidence that shows that differences in things like poverty in childhood, exposure to various kinds of trauma, it does create disparities that are known and measurable, right, in mortality. We know that there are big differences, for example, in the United States in life expectancy by race. There are big differences in life expectancy by education, right? And so there are really clear, there's really clear evidence about these disparities in longevity. And then the impact on health turns out to be a little bit more mixed, right? So we find these differences in some chronic health conditions, but not in others. And when we look at, when we use our longitudinal data, which researchers on aging for a long time were saying, like, we should collect more data, we should follow people up over time, let's not just look at people at one point in time, but try to understand the way in which health unfolds over time. It turns out that the findings are often mixed. We often see that there are baseline differences between groups of people, whether it's defined by race or socioeconomic status. There are baseline differences in health, but then the pattern of health change over time, we don't often really find strong effects there. It's a very mixed literature. And so the question that I have in thinking about this is whether these mixed findings are a result of sort of a truly sort of the difficulty true difficulty that there may be in predicting patterns of health. But I also wonder to what extent this initial sort of mix-up of two intuitions that I talked about a slide ago, though it might seem a long time ago, to what extent do our statistical models reflect kind of a heterogeneity in individual histories or not? Right? Is part of the puzzle here the fact that we tend to use statistical models that assume that health changes gradually, when for individuals it may or may not. Right?
Is there like a canonical example of where you don't see the predicted effect with the trajectories?
So there is a series of papers that came out in kind of like in the last 5 or 6 years that use either growth curves or latent class models to look at racial differences in a variety of outcomes like functional limitations or depressive symptoms or disability. And what they often show is sort of like parallel trajectories for groups defined by these demographic characteristics, where there's sort of like baseline differences and disadvantage, but then the actual projection, the actual sort of progression of sort of accumulated limitations or accumulated disabilities doesn't vary. So there's differences in intercepts, but not slopes. And so I'm going to sort of focus on this idea of this assumption of gradualism. So I wanted to make a little clearer kind of what I mean by that. Because it's actually not an assumption that we usually think very much about, and it's not an assumption that we tend to sort of test our data for. And it is what we are going to do here, right? And so gradualism is just this idea that change happens, right? Slowly, steadily, continuously over time in a way that allows you to kind of draw a smooth trajectory, right? It can be linear, it can be curved, but the idea is that it's sort of a continuous process. And when we think about gradual change in terms of health, it actually makes sense. There's a reason why this model or this assumption has been adopted by people for a long time. And that is that, first of all, sort of biologically, it seems very intuitive and compelling, right? Particularly on a subclinical level, health probably does change in an incremental fashion, right? Like we're not always constantly sort of consciously aware or attuned to how our, sort of heart rate or blood pressure or other things are moving unless we have reason to think about it in particular. But these things probably do change in an incremental fashion until some threshold, right, of health change happens that we become aware of. So it makes sense to think that kind of in underground, perhaps health is changing in this incremental, gradual fashion. It's also super convenient statistically, right? Because if health is changing, right, it's changing in a gradual fashion, that means we can model it with parameters, right? It has an easy functional forms that we can graph, we can run analyses, right, on the smooth pattern of change. We can try to figure out what the intercept is, what the slope, right, what the curvature is, if we think it's a curve. And so because it's statistically convenient and biologically compelling, it has been really sort of productive and fruitful in allowing people to generate really clear hypotheses about how health might change in relation to sort of in older populations in relationship to a variety of exposures, right? So do we see differences between different groups that have been exposed to different kinds of disadvantage, right? Like discrimination or poverty. We can ask questions like, do people who have different kind of occupational exposures have different patterns of health decline over time, right? It allows us to ask clear questions, set clear hypotheses, and then these statistical properties let us test them very conveniently, right? And so there's reason why this is happening, but it's not completely clear to me after starting to look at individual longitudinal data on health that this assumption is consistent with the data that we have about the health, both the kind of health processes and the survey processes, right? The fact that we actually don't follow people usually continuously over time, but rather we have surveys that check in with them at discrete points in time, right? So both the survey process and the underlying health process, like, do they really sort of work in this very steady, gradual way over time? And so what we did is we used the health and retirement study because it's a nationally representative study of older adults. It's also kind of the major source that people use to do analyses of longitudinal change in the US. And we looked at members of this health and retirement study cohort and we looked at them, right? The survey checks in with people every 2 years. And we looked at a variable of functional limitations, and functional limitations, in the interest of time, I won't go through all of this, right? But functional limitations captures a variety of different indicators, and we basically give people a score that ranges from 0 to 12, and it counts the number of particular tasks that they indicate having some difficulty performing, right? And so why am I looking at functional limitations in order to try to understand kind of gradualism versus other methods? So I apologize if you can't see this, but this is kind of this classic model from Verbrugger and Jetty of the disablement process that says, you know, the pathway towards disability starts with some kind of pathology that perhaps creates functional impairments, some kind of dysfunction, right? And then functional limitations, which are the things that we're measuring, and that eventually ends up manifesting in disability. And of course, all of these things are affected not just by factors internal to an individual, but are also modified in many ways by the environment and other psychosocial factors. But it's a very useful measure, right? It's useful when we think about health decline, because we can measure kind of the accumulation of limitations over time, right? And so in the absence of sort of a really excellent global measure of health, researchers usually use things that are available. So we count things like either number of chronic conditions that people describe, or some very severe types of disability. Functional limitations kind of fit in between very severe limitations and having some kind of chronic condition. But because of that, because there are sort of 12 of them, you can accumulate them. They're not super severe, but they're not something like a chronic condition that people sort of, some people have multiple chronic conditions, but we don't necessarily expect those to kind of accumulate indefinitely over the life course. They're actually the likeliest of all the health measures that are available in large surveys to display a gradualist paradigm, if it really exists, right, than other measures of health. So we use functional limitations, and, right, you were asking before, Josh, about, you know, what are some examples of studies. This is actually the measure that most studies who have employed this approach of trying to track longitudinal patterns of health and understand disparities in them, this is the measure that many of these studies favor as well. And so what we do with this measure is we actually model patterns of change in functional limitations in the HRS study using 5 different methods that give us different conclusions, right? And I'm going to sort of, this is a little bit unorthodox. I know we're used to sort of data, methods, results. I'm going to show you methods, results, methods, results, methods, results, just so that you can see that this ends up taking us in different directions, right? So first is kind of the classic latent growth curve. This is where a lot of sort of current longitudinal analysis of health gets its start, right? So we have repeated measures of the same variable, and we use them to model trajectories of change of health in the population. Now, you can do this in a sort of structural equation framework or in a latent class framework. The basic intuition in both of these is the same. It assumes generally that individuals come from a single population that can be described parametrically with an average trajectory, right? And then they also have, it also yields other parameters that describe heterogeneity around both sort of the intercept and the slope of change. But the idea is that it still assumes a single population and it's modeled parametrically. And that parametric assumption, right, that's where the gradualism comes in, right? Because it assumes that whatever that parameter is, it means that the change is happening at either sort of a constant or a constantly changing rate in the population. And so, right, so there may be heterogeneity around that within the population, but we can sort of fruitfully describe the population in some meaningful way using this. And so when we do this in the HRS, and I should say in all of these analyses that I'm going to show you, at least in the first part of the presentation, that there are no covariates. We're just trying to see whether we get the same results modeling patterns of functional limitation over time. And so what this shows us is kind of this classic idea, right, that on average, respondents in the HRS we start at round 2 rather than 1 because they change the measurements between 1 and 2, but since round 2 and subsequently they have used the same question to measure functional limitations, we see this kind of gradual accumulation of limitation, right? So there's a relatively low number of limitations on average in the population, and then it increases, right, as the respondents get older, right? It doesn't reach super huge levels, but it increases, and this is just what we would expect. Now, if you look at sort of the back end, right? If you look at the table at the outputs that show you heterogeneity around this estimate, the heterogeneity is really, really big. It often is for papers that use this model, but much of the discussion focuses on kind of this population mean, while acknowledging that there is heterogeneity around it. So that's kind of one approach, right? And it shows us that, you know, we use a model that has a gradualist assumption baked in through the parameter, and we get a trajectory that sort of reinforces what we think, which is that population aging is associated with gradually accumulating functional limitations.
What does sample estimate mean?
Oh, so we have this is just the averages in the sample, and then the estimate that's generated by our model based on the parameter. So, and then another way that people have approached this is to say, well, one thing that is unsatisfactory by this idea that you can describe the whole population using just a single growth curve is that, you know, just because we have a single population doesn't mean that everyone is equally well described by a single population average. It may be that there are multiple meaningful classes of individuals that follow distinct trajectories in the population. And so latent class growth analysis is basically a development from these basic models of the growth curve that allows you to create multiple classes, right? And these can either be classes where you assume that everyone in the classes is homogeneous, or like growth mixture models, you allow for there to be internal heterogeneity within this class, but you still think it's useful to differentiate multiple classes rather than consider everyone as a single population, right? And this is very appealing because the gerontology literature for a long time has emphasized that older populations are very heterogeneous, right? Because of differentiation over the life course and because of cumulative advantage and disadvantage. So it would be really nice to be able to see different patterns of health, and it's also very nice to see whether exposure to particular kinds of disadvantage in early life may sort people into following, say, trajectories of decline that are faster or slower, or perhaps more stability over time. And so these models, right, are trying to both to look at intra-individual, so within person change over time, but also recognize that these things vary across groups of individuals over time. But these are also parametric models that also assume that for each of these groups, right, we can capture heterogeneity, but we still assume that the rate of change within each of these groups is constant or constantly changing, because there is still a parametric it's still a parametric model, and so it allows us to still make assumptions that health changes when it does, is doing so gradually, right? And so again, if we look at the results, right, same data as before, but we apply a latent class growth analysis to it, we see that it says, you know, no, there's not just one population. So before, if you remember, we had one population, we started with an average of about 2 limitations, and it increased up to about 4. This model, right, says actually there are 4 different groups in the population. This is the best fitting model. We tried a variety of different classifications that ranged from 1 to 6 classes, and this was the best fitting model. And so it says, the vast majority of people, 65%, start off with very low levels of limitation. This is just like that first graph before, but at a lower level. They start at 1 and they gradually accumulate more so that on average there are about 2 at the end. But there's also another class of people, right, who start off with relatively low levels of limitation, but then accumulate them very fast, right? These are maybe people we might be particularly worried about, right? Like something might have happened and then they're really increasing in their limitations over time. There's another group here that starts off at relatively high levels of functional limitation in the beginning also, and they increase a little bit over time at this higher level. And there's only one group, Group D, that has about 8% of the sample that shows any kind of improvement, right? That shows any kind of decline. These are sort of the people with the most functional limitations. And so you can read that as these are the people who are improving over time, or if you're a demographer, you might say this is probably because these may be the people who are ill and maybe most vulnerable to mortality. So maybe this is actually just selection, right? Changing population composition over time. And it's only changes in population composition that allow these models to even include the possibility of recovery. And it's probably not even right for that case. Yeah.
And my understanding from the title that says latent gross analysis, that this comes from fitting the mixture model to the actual dates of transition.
Right.
But it is not using a suite of other variables at baseline.
No.
They're not groups defined.
They're not groups defined on anything. This
They're
is
intrinsically
coming up as like these are patterns that are similar in the population. Exactly. Yeah. Yeah. Right. And so again, this is capturing heterogeneity in some sense, but it's still not saying that some people might not experience, right? All of these actually, right, show that there's, in many ways, not actually that much change within each group except for group B, right? That it sort of hints at us that like, there's actually a relative amount of stability, but because of the parametric form, in order to get from here to there over the course of the survey, you have to sort of show this slight increase over time.
So could I ask, so it examines all the data at once, all 10,000.
Yeah.
And it extracts, that's what the method is doing. It extracts these different categories, these different groups.
Right, these different classes of people whose trajectories are following similar patterns, right? And so this is from a latent class growth analysis, so it just estimates the average population, the average trajectory for people. And that, if we did something like a growth mixture model, you would be able to also estimate more explicitly a parameter for how much heterogeneity there is within each class. So. But right, so it's basically still saying these are basically the best way of characterizing the average patterns, but within these groups rather than for the population as a whole. And so next we were like, okay, how about we just look at descriptive statistics?
And I'm sorry, and so you can also, like analysis of variance or something, say how much of the variation has been explained by you're dividing it into 4 groups, right, versus the.
You could, yeah. So this might be a little bit hard to see, but one thing we did next is to just sort of say like, wait a minute, like let's just look at how much change people are actually experiencing in the sample. And we looked at functional limitations, which is what I've been talking about over here, but also comparing it to chronic conditions, which you can see from the numbers, right? People have fewer of those over time. And then limitations in activities of daily living, which is a measure of more severe disability. And what you can see, right, is that if you look between the kind of first round and last round observed, right? This is what we expect based on the growth trajectory that I showed you before, is that on average, the number of limitations, right, is increasing between the first and last round. This is also true for chronic conditions and for limitations in ADL. But not everyone actually increases between the first and last round, right? So only about 59% of the population actually experiences, if you just look at how many functional limitations they have at the first round that they're observed, in the last, it's about 60%, right? There are 25% who actually see no change at all between the first and last round. And then there are 16% of the population that actually have fewer limitations at the end than they did in the beginning, right? And this is, but this is sort of underestimating, because things might happen in the middle that you don't capture by just seeing what happens in the beginning at the end. And so it is the case, right, that actually a lot of people experience some increase in functional limitation over the course of the entire survey, 79%, but it's not nobody, right? There's 44% who also at some point experience a decline in functional limitation, so they're getting better, an improvement, and there's 9% that see no change. Right? Yeah.
And improvement or a change of 1 on the scale counts for improvement or
Right.
Okay, so
Right.
that,
So it's, they report. It means they've reported having difficulty with something
so they
in
go
one
from
survey.
3 to
We go
4,
from 3 to 4, or from 4 to 3.
even though some of that might be just reporting noise.
It could be reporting noise. We looked at it to see whether that happens, and we don't think it is, because it's stayed relatively consistent. There are not a lot of changes that kind of go up, down, or sort of blimps. As I'll show you, what happens is there's sort of like stability, some change, and then stability at that level again. So we don't think it was just reporting noise, but some of it certainly might be, but I don't think it's what's driving the effect, right? Yeah, so I'll speed up. But so these were just the basic descriptives. But another thing we tried to see is, how many people actually experience sort of successive increases across multiple survey rounds in the number of functional limitations that they report. We have 12 survey rounds, and obviously, right, like nobody experiences an increase of 1 every time. Literally nobody does, right? Most people, in fact, report, right, no change or just 1 or 2 changes. There are very few people who experience multiple, right, successive increases in functional limitation, which is not necessarily what you would expect.
Over 2 years, is that the same?
No, it's over the full 14.
Over the full
14 weeks. Yeah.
This change would be an additional kind of limitation or increasing severity in limitation?
It's just an additional report. It's any kind. So each one is a dichotomous measure. So it's just, yeah, we can't capture changes in severity there, right? And so the fourth method out of 5 is to use multi-state life table and looking at transition probabilities. Now, this is nice sort of in comparison to just descriptive statistics or the trajectories that I showed you before, because it can account for these competing risks, including mortality, because we think that when you're studying health in later life, mortality and attrition are not random. They are intimately related, right, to the outcome that you're looking. And this looks at that sort of whether transitions happen rather than their timing. And so this is actually not a gradualist model. It's discrete. It just looks at whether changes happen or not. It doesn't assume that they have to happen continuously, right? And sort of the model allows people to move between different states of limitation to a state of kind of temporary missing, meaning they're missing on a particular wave, but then they come back, or they're sort of absorbing states of dropout or mortality. And so what we see, and because of the ways of calculating this model, we can look at changes. The blue curves are between round 2 and 5, between round 6 and 8, or 9 to 12. The probability, right, across these different survey rounds, the most likely occurrence for anybody, no matter what state of limitation they start in, is staying in that same state, right? They just, that's the most common outcome. It's particularly outcome for the healthiest people, right? It's a little bit less likely for people who start off with a higher level of limitation, but even these folks are most likely to just stay in the same category that they were in before. And for interest of time, right, I'm just gonna show you, right, so you can see that the diagonals are the people who are staying in the States, but the reason to show you this in addition is because we can also look at improvements, right? So people who start off at 2 to 5 or 6 to 12 and end up with lower levels of limitation, like the multi-state model actually shows us that there is considerable recovery. So there's, unlike the gradual model that kind of emphasized the change over time, these models tell us there's a lot of no change, there's a lot of stasis, and then there's also a lot of just of recovery that's not being captured by those models. And so the final way that we looked at this is using sequence analysis, right? Where we just look at kind of the ordered series of events, and it's similar to the latent class analysis in that it generates these clusters of trajectories that are similar to one another, but rather than doing kind of a parametric model in order to do that, this is also a non-gradualist approach, right? Meaning that it's flexible enough so that if the trajectories are gradual, it will show us, but it can also show us other patterns, including ones of stasis or of recovery. And so what happens here, let me see if I can show you this. So Heidi made this awesome graphic that actually moves. This is what actual trajectories of individuals look like, right? They take a whole lot of different shapes. There's kind of movements. This is 50 randomly selected ones. We can see some up and down. We can see changes, right? But there is not a lot of just gradual increase in recovery, right? There's sort of a lot of noise, right? And in fact, it's so noisy that when you look at, we asked, R to tell us, like, what are the most common trajectories that you can see? The most common sequences are ones, and all of these graphs are the same. They show levels of limitation going up from 1 to 5, 0, right? They show temporary missingness, attrition of people who are lost to follow-up, but we know that they haven't died, and death. So the most common kinds of trajectories are one where nothing happens, right? Trajectories where people were in the study but dropped, right? But were lost to follow-up really quickly. Trajectories where people were in the study but died, right? Around where you see people who are healthy, right? So most of these most common trajectories are ones where there's kind of one small change and then there's flatness, and a lot of this is being driven by mortality and dropout from the study rather than a change in health, right? So there may be some ways in which the models that we saw before are showing us kind of an aggregation of how individual health changes, but they're also showing us, what they're showing us is driven to a large extent by the changing composition of the cohort as it's aging. And then we said, well, so that showed us a lot of nothing. What if we condition on having experienced at least one change, at least one increase in functional limitation over time? Does that show us more gradual trajectories? And the answer is, still no, right? It still shows us mostly flat trajectories with kind of one increase, but oftentimes in many of these cases, the increase is followed by recovery and then kind of continuing stability. And so the summary of this part, right, shows us that there's a lot of stability, and even though change is common, right, for individuals and in the sample overall, for individuals, it actually happens sort of relatively rarely over the course of their own life and their own participation in the survey. And to the extent that change does happen, it happens at sort of heterogeneous times, directions, and paces, and it suggests that sort of the average trajectories for the population or for subgroups don't accurately represent the experiences of most individuals, right? It's true on a population level that health changes gradually, but what does it mean that for individuals, right, change is actually very rarely gradual and continuous? It actually looks more like what we call punctuated equilibrium. Right, so I'm borrowing this metaphor from Stephen Jay Gould and Niles Eldridge, who basically coined this term when they wrote a paper in the early 1970s challenging sort of the orthodoxy in evolutionary biology about speciation. right? So the gradualist orthodoxy, as they talked about it at the time, was that species kind of evolve linearly from one type of species to the other, because in the fossil record, right, you would just see kind of changes over time as one type of species evolved into another. But their claim, and the problem with this model, is that the fossil record wasn't that smooth. There were breaks in the fossil, it was missing data, it was problematic, but people kept trying to say, well, it's really an underlying gradual process, we just have some missing data. And they said, well, what if it's not just missing data? What if in fact the process is not gradual change, but rather an evolution that kind of proceeds in breaks and fits, so that for most of the time, things are staying the same, and then this equilibrium is punctuated by big changes, right? And they point out, and I think this is true in this case, that these two perspectives are not necessarily contradictory, right? Underlying, just as I said before, underlying change can happen continuously, but what we observe, right? What we observe in the data, because of when we check in with people, is actually happening on a discrete scale. And so we're reading it on a different scale. And then I should also say, sort of by way of a disclaimer, since we do have a biologist in the room, is that, right, in evolutionary biology, this idea of punctuated equilibrium is used to talk about the emergence of new populations. And here I'm not arguing that that's what's happening, but rather that gradualism is an emergent property of populations that does not actually hold at the individual level. That individuals experience things sort of as a punctuated equilibrium, but as a result of sort of the changing composition of the aging cohort, we assume that gradualism is what plays out overall. And so we make these assumptions that aging is a time of gradual decline. We use models that have that assumption built in, and then we get results from those kinds of models that reinforce those assumptions of what aging looks like, even though it doesn't seem to for most individuals who are actually growing old, right? And so what does this mean for research on health and aging research? I'm going to try to, this is kind of the newer part, which I should have tried to get to a little bit sooner, but I'll try to still give you the key points, right? So it reinforces this intuition about gradual health decline. And so I think that's part of why, when we try to test these cumulative disadvantage hypotheses about how health declines over time in groups, we see differences in baseline, but not differences in the slope of change. In some ways, it's giving us back the assumption that has been baked in, because these models don't do as good a job as some of these other approaches that do take into account the discrete nature of kind of a punctuated equilibrium experience of aging, at least as reflected in survey data. Then they're particularly likely to actually underestimate poor health and mortality in disadvantaged populations. And so one of the things that we're trying to do in sort of moving this forward, right, is move away from this sort of classic population logic that says, you know, using these aggregate models is useful because things that seem highly contingent on an individual level might still be predictable at a higher level of aggregation. This is why we know, right, that smoking is, you know, deleterious to your longevity and to your health, because on a population level, that risk is really strong and clear, even though you can always come up with the case of an individual who smoked but lived on a long life, right? But then the question is, would an analytic approach that, rather than having a gradualist assumption, and it would capture this notion of like punctuated equilibrium on the individual level, does it actually help us think a little bit more about the relationship between structural factors like inequality, right, the social inequality and health, or is it just kind of a mess because there's too much heterogeneity to say anything meaningful? So I'm gonna skip in the interest of this and just show you kind of a couple of preliminary findings, again, that are just looking at the HRS descriptively and using multinomial analysis, just to show you why having this kind of punctuated equilibrium mindset might illuminate some things. This is just looking at differences by race and gender in the HRS sample, looking at folks who have improved health, stable health, declining health, loss to follow-up, and mortality. And what's interesting here is if you look relative to sort of their white counterparts, same gender counterparts, it looks like sort of Black women and Black men are more likely to, are less likely, sorry, to experience both stable and declining health, right, relative to their white counterpart, but they are more likely to experience both improved health and mortality. Right? So the pattern, the inequality in mortality is not necessarily always reflected in more health decline and in more stability. It's a little bit puzzling, right? And then likewise, if you look at this, right, at the patterns of health relative to the patterns of mortality, right? The folks who stay in the sample, this is people who stay in the sample all 12 rounds, folks who are lost to follow-up relative to people who have died. The people who have died actually are more likely to experience health improvement relative to people who stay in the sample longer, right? Like you have to have more exposure time in order to develop poor health. And so there's this counterintuitive finding there. Yeah.
Sorry, quick question. White women or whites and blacks are at different baselines. So
Right. Yeah.
We would consider that if Black women and Black men are starting from worse health, their improvements relative to white women and white men who are starting higher health. It's something to consider. It's not what I'm saying.
That's a good point. Yeah. So I'd have to think a little bit more about that and sort of the levels and where.
But otherwise, that is very interesting.
Right. This is just a suggestive kind of initial finding in the sense that like we think of health and mortality as moving together, but in some ways there is already a level of advantage in surviving to an age when you are old enough to start experiencing worse health or the pattern of health decline. And so just expecting groups to have different disparities in the decline on that is the reason. And so I am way out of time, so I'm not going to show you all these results. I'm just going to say that we did a series of multinomial models that look at predictors of a variety of kind of indicators of disadvantage. So lower levels of education, right? Parental education and smoking to see whether they predict having a health improvement, having stasis, loss to follow-up, or mortality. And we find that these kind of classic measures of social disadvantage are much better at predicting mortality and survey dropout than they are any kind of health change, right? And so we think that what this means that the way in which early life exposures and markers of inequality influence health disparity in later life is not by making people who experience disadvantage necessarily less healthy. It actually operates primarily by shaping the composition of the cohort that actually survives into midlife and older age in order to experience these kinds of disadvantages. And so the same factors are actually less informative for predicting a longitudinal trajectory of health than they are to predict baseline differences or even mortality. And so what that means is that unlike public health interventions that say we're going to use individual level data and then statistical models to make analysis about risks at population, and then we're going to take that and tell individuals that they need to change their behavior in order to be healthy or to slow health decline by exercising or eating better or not smoking, we've translated that back into the individual level. That actually is much less likely to actually work in improving health or slowing health decline than a kind of more structural type of intervention that deals with the roots of disadvantage in early life and in dealing with things like racism and economic inequality, because those things influence mortality much more strongly than health, and it is addressing that that might actually have a bigger impact on population health. So thank you.
We're right on time. Fine. So, tell you a couple questions before 1 o'clock, and then we'll give you a bunch of I see many of the usual suspects. Why don't you call people? Less biased.
I don't know. Okay, let's start with you. Yeah.
Okay, thanks for the talk. I'm just curious about this idea that you're, how do I say it? The survey data is the HRS, which is 55 years and older.
50 and older, people were 50 and older in 1992.
So do you think it's possible that if you were able to get similar data for a younger, you might find something different because of, in terms of how these disparities play over life course, in terms of this punctuated equilibrium versus a gradual?
Yeah, I mean, I think getting data that starts earlier will be a lot more informative about what happened to people, sort of like why are these differences at the baseline of 50 what they are. And so, yeah, I think definitely that will be informative. I think, what happens is that the intuition about when health declines, a lot of health decline happens at the very end of life rather than over sort of a longer lifespan. So it'll also be interesting to think about how well these models apply to, say, a 60-year period as opposed to sort of a 20-year period. Yeah.
Very interesting. Very, very good approach. Did you try time series type models of health status? Because I think I would have started with the idea that, okay, health status now is some function of health status previous period, plus some drift turn, plus some innovation turn that might have a big variance. And then depending if health status now equals health status before, then you have a random walk type thing where the errors persist forever, and where you are is kind of the sum of them. But there can also be a tendency for these shocks to wear off to some degree, so that maybe most of the time you stay in the same status, but sometimes you're improving a little unless the drift and so you could imagine each individual at the start, at age 50 or whatever, has their own time series process like this. Maybe they share, they're going to start at different levels. Maybe they all have the same degree of auto correlation, something like that. But maybe they have different drift. I don't know. But that might lead you to different kinds of conceptualization and statistical.
Yeah, it's super interesting. We haven't done it. It would be really interesting. I think that it could lead us to different thoughts about kind of the pattern of change in health in people who stay in the survey for a long enough time to experience these changes. But so much of what we find is being driven by mortality and attrition rather than kind of these actual within-person change in health. And so I'd have to think more about to what extent this kind of modeling approach with the time series, like how does that take into account non-random mortality and loss to follow-up selection in trying to describe these longitudinal.
Well, a big question would be, is the mortality risk a separate process, or is it when health status drops below some threshold? Probably it's really a separate process.
Yeah, and I think it's not. Right?
I
think it's really, I think people die after they get sick. I think people are more likely to drop out of the survey when they're not healthy enough to sort of keep wanting to participate. And so I think some of it is certainly different and maybe random. Right? Like there are accidents or things that are totally unexpected. But we've done a little bit of this looking at sort of what people's health is like before they drop out in order to understand that. And I think that people are dropping out for reasons that are not unrelated to their health, which means that we have to think about how to model mortality as part of that process. But
So I did one quick comment then. One difference between your health measures and mortality and attrition is the reliability of the data.
Yeah,
pretty clear.
Right. We know when someone's dead.
Or treated, but this other stuff, what somebody considers difficulty walking upstairs, another person might consider to be normal. So,
sure.
But my question would be, in the growth models, you show one very distinctive class that shows this escalating.
Yeah.
My question is whether the sequence analysis tells you something about that group. That is, does the sequence analysis identify a set of people who in fact show what you would guess cumulative dysfunction?
So whether do we also see that in the sequence analysis? So the sequence, the two figures, and I went through it quickly kind of show us the biggest classes that the sequence analysis identifies. And so that didn't come up as sort of one of the biggest classes, which doesn't mean that it doesn't exist, but by biggest classes, I mean classes that show us the biggest class. See if I can go back. The biggest class sort of originally, when we looked at everything all together, had only about 239 people. And when we looked at the ones that at least experienced some kind of decline, the 12 biggest classes ranged from 25 people to 9. And part of this is just because the sequence, like to be part of the class, you have to have exactly the same trajectory, and people are variable, right? And so you might want to group things together that shows, that'll give it some more flexibility about the timing of increase. And so our particular kind of pass at the sequence analysis didn't identify a whole bunch of people with this rapidly increasing group, but I think that's a limitation of the sequence analysis rather than the idea that there aren't people who experience
But do you have now some idea why that group popped up? Is it a statistical anomaly, or is it?
No, I mean, there are people who experience sort of rapid increases in limitations. Usually it's right. It's after some kind of event, right? Like there's a fall, or there's been or there's been something like a heart attack, and then they accumulate kind of multiple limitations all at once. But it doesn't necessarily get identified by this other method. So I don't think it's necessarily that there aren't people like that, and it's completely a statistical artifact. But it's also right. But it's even that category. If I go back to this very rapid thing, it still has to. Oops, sorry. It's a small percentage, but it's still like what I was trying to do there is think about the gradualness, right? So even this, it's a rapid decline, but it's this very smooth upward trajectory. And I'm not sure if that's really how people experience it, or if it's just a bunch of people who jump at various points from having like none to multiple at different types. Yeah.
That was very stimulating, everything enjoyed it. Thank you. I'm wondering though about the role of the measures you have with health and the way they're driving this metaphor. So if I have a different kind of metaphor in mind, I'm thinking about tires. The way tires work, right, we can expect a very kind of gradual weathering. And yet if you ask me how many times have you changed your tires, I can tell you like I either have or I haven't.
Yeah.
So I guess the question is just, do we only measure health as kind of tire changes, or as like wear on the tire? And you're effectively kind of doing it at the change level, and I wonder about that. I wonder if that's really the thing that's kind of pushing you towards this punctuated equilibrium model.
Right.
Yeah, maybe right. It's
punctuated.
Right. So I think I actually like this tire metaphor because I think it comes back to this idea about how the gradualism and the punctuated equilibrium are not necessarily in contradiction to each other. Both of these are probably happening, right? The health probably is changing on a gradual level for people a lot of times. But the reality is that we are, and that's probably why we feel comfortable applying models with that assumption to health data, because that resonates with us as intuitive. But the reality of the type of data we collect is that it's not continuous, right? We do check with people at just these like discrete time points, and all we know is what they tell us, which is a function of kind of what has gotten to their level, past their threshold of observation for them to report on. And so I think, it's not so much that I think punctuated equilibrium is right and gradualism is wrong, is that I think they both can be right, but they have to be tested with different types of data, right? So we can either stick to our gradual measures, but then we should not necessarily use discrete survey data to measure it. It would be better to use some kind of data that we can use to say continuously monitor very subtle changes in health, and then we can apply these kinds of model to, right? So some kind of like continuous biomarker measurement or something like that. That might work. It might not. It might actually show a lot more variability that we're not capturing with these more extreme measures, but it's possible, right? Maybe we can look at it that. Or, right, if we are going to stick to this survey data, which has served social science researchers really well for a long time, and we're going to really just check in at these discrete increments, we should recognize that that we can't just assume that these discrete increments are picking up points along a gradual trajectory, but there are things that happen that may be sort of usefully illuminated by recognizing the non-gradual nature.
Okay, so I see Gene has given up his last question to Ken. Are you giving it to Ken? You're letting Ken ask the last question? So go for it.
So, in your analogy to Eldridge and Gould's punctuated equilibrium, you're putting the punch on punctuated. But for Eldridge and Gould, the centerpiece was equilibrium. That is the thought that adaptive processes within periods of stable environment optimized
Right.
fitness.
Yeah.
And so something had to change before the balance that had been reestablished was no longer optimal.
Yep.
Now, in your picture, we talked a lot about punctuation, but Ron brought up this question of where is equilibrium in the model. And I was thinking about this, and if I understand the cohort that you're following, you are not describing processes among the oldest old.
Right.
This is a cohort which is still in moderately young old ages.
Right.
If you did this, if you went on, as you likely will, to then shift to another HRS cohort and look at what is happening between 80 and 100, your patterns would be different. But one of the most important things to find out might be the frequency in which equilibrium can be reestablished.
Mm-hmm.
So there's one is describing it exactly. There's a exogenous shock. You fall, you break your leg or something. But it's important knowledge if typically there's then a return to functionality
Mm-hmm.
from whatever exogenous processes are changing. I think you're looking at too young a cohort, not yet old enough to see a lot of this, but as you move into the older cohorts, I think looking for that equilibrium, the adaptation, something that happened, but you got over it,
Right.
either with treatment or just a condition ceases to be a limitation because you learn how to make the best of it. That's, to me, an important theme that will interest gerontologists as you go forward.
Yeah. So I think that this idea of stasis is to me kind of equally central as I think the punctuated gets some attention because we are interested in change, right? Things staying the same sort of don't make for very compelling stories to a lot of people. But I think one of the things that our analysis kept showing is that like it's the gradual assumption that assumes that change is always ongoing. But the punctuated equilibrium approach actually keeps showing us like most of the time things don't change, people stay the same, right? And you know, when you look at these models, like the sequences, they're mostly stable, they're mostly straight, right? Even once there is a change, people then seem to sort of reestablish another level. So I agree that I think the equilibrium is as much of the story here as the punctuated, particularly because I think that's the part that speaks most to these initial kind of two intuitions. Is aging really just a time of continuous decline or not? And I think the answer is it's usually not, right? Like at the very oldest ages, right? At the very end, like everyone dies at the end. So there will be some kind of decline, but that's different than thinking about sort of the very, very end of life versus sort of older age broadly defined as, you know, as sort of the second half of life as is likely to be for these HRS cohort members who are likely to live a long time, right, past 50. And so, which is a long way of saying I agree.